Okay, so just looking at divisibility with indices. Okay, so first of all, we just prove true for n equals 1. So 3 to the 2 times 1 plus 2 to the 1 minus 1 is 3 to the 3 plus 2 to the 0. So that's 27 plus 1, which is 28. And 28 is 7 fours, so it's definitely divisible by 7. Okay, so assume true for n equals k. Okay, so that means that 3 to the 2k plus 1 plus 2 to the k minus 1 equals 7m, which is divisible by 7. So it's a multiple. And then we're going to prove true for n equals k plus 1. Okay, so you want to required to prove that 3 to the 2 k plus 1 plus 1 plus 2 to the k plus 1 minus 1 is divisible by 7. So it'll be 2k plus 2 plus 1 plus 2 to the 1s will go out, 2 to the k. That's 3 to the 2k plus 3 plus 2 to the k. Okay, so the next step, we then have to basically, we take this here and we go 2k plus, now we've got our assumption, which I highlighted up there. We create the assumption, which is 3 to the 2k plus 1. And we take the 3 to the 2k plus 1 and solve for 7m minus 2k minus 1. So you rearrange it. So I'm going to make, I'm going to sub something in for 3 to the 2k plus 1. And that'll be 7m minus 2 to the k minus 1. Now, in order to make it the same thing as when it was true for n equals, that's this one here. I'm just going to make that a bit better than that. So we've got 3 to the 2k plus 3. So that means you have to go 3 to the 2, because 2k plus 1 plus 2 is 3 to the 2k plus 3. And that'll be 2 to the k. Okay, so the next step is we sub in, that's 3 squared, for the 3 to the 2k plus 1. And we put in 7m minus 2 to the k minus 1 times 3 squared plus 2 to the k. Okay, so that's 7m minus 2 to the k minus 1 times 9 plus 2 to the k. Expanding that bracket, 7 nines is 63m minus 2 to the k minus 1 times 9 and 2 to the k. All right, so this part here is divisible by 7 because it's 7 nines is 63. So that's all good. I don't have to worry about that. What I'm going to do here is if I look at 2 to the k minus 1 and 2 to the k, what I need to do is I need to factorize it. Now, when you're choosing what to take out the front, you take out 2 to the lowest indice. Because if you take out the one with the lowest indice will be contained in the bigger indice. So for example, if you go back to basics and say you have 4x squared plus 7x4, then the lowest indice here would be 2. So if you take x squared out, x squared times 4 gives you 4x squared. And then if you take an x squared out of x4, that would be x4, because x squared times x squared is x4. So now if you apply that same situation here, the lowest indice, is it 2 to the k minus 1 or is it 2 to the k? And the answer is 2 to the k minus 1, because k minus 1 is smaller than k. So you have 63m minus 2 to the k minus 1. What would be left? 2 to the k minus 1 times 9 is left. Now you've got to also be careful that if you take a minus out, the sign inside here will change. That has to go to a minus, because a minus times a minus is a plus. Now I took out 2 to the k minus 1 times 9 will give you 2 to the k minus 1 times 9. But when I do it on the second section here, 2 to the k minus 1, how do I end up with what's above it, which is 2 to the k? So what would that be 2 to the power of? See, 2 to the k minus 1 times 2 to something, then you want to get 2 to the k. So if you make that number a 1, see, k minus 1 plus 1 gives you k. So you've got to choose an indice here so that when you multiply it by the one that's outside and you add the indices, you get what you started with, which is 2 to the k. I'll just give you an example of something else. Say it was 5 to the k minus 2 times 3, say, minus, we should make that a minus and a plus. 5 to the k plus 1, we'll just leave it at that. So what's the lower indice? 5 to the k minus 2. And I'm going to take the minus out. So 5 to the k minus 2. That means you will have the 3 left. The sign inside changes to a minus. And this will be 5 to the power of what? So 5 to the k minus 2 times 5 to the power of what? You're trying to end up with 5 to the k plus 1. So what would you have to add on to the k minus 2 to get k plus 1? So it'd have to be plus k minus 2 plus 3 would give you k plus 1. And that's what would be left there. Okay, so let's just remove that and let's go back to the one we're looking at. Okay, so you can see that what was left inside here was 2 to the 1, because 2 to the k minus 1 times 2 to the 1 will give you 2 to the k minus 1 plus 1, which is 2. Okay, so now just looking at that, you'll have 63m minus 2 to the k minus 1. 9 minus 2 is 7, so there's a factor of 7. Common factor in 63, and this term would be 7. 7 times 9m would give you 63m, and 2 to the k minus 1 times 7, we'll just leave it with 2 to the k minus 1. Therefore, it is divisible by 7. So, therefore, by mathematical induction, it's true. It's true actually for all n greater than or equal to 1.